everyone, and welcome to the second part in our RustDoc class, or, probably also the fourth part, because we've had some bonus content. But before we get into the class, I just wanted to announce something really quick pertaining to this Rust class. If you're liking these and want to join in a little bit more actively, on Tuesdays and Thursdays, I'm going to stream kind of part of the lesson live on Twitch. So if you want to join that, if you want to see that a little bit beforehand, you can live interact and ask me questions as we're doing it. So we'll kind of do the lesson, and then I'll be able to take your questions. I'll hopefully be able to answer most of them, and I'm going to be able to bake those into the videos, so the long-term videos that people get to watch get to have active questions answered. So things that I might not have thought to cover, I'm going to get to cover in the videos because of your all's input. So please join me on Tuesdays and Thursdays. I also stream on Saturday. Saturday is a fun stream and where we do something ridiculous with computers. And Sunday is my news. So go ahead and join me on stream if you'd like to do that. Otherwise, let's go ahead and get into the lesson. Today, it's all about testing. You might be thinking, oh, Merrick, aren't you going to teach us flow control? No, flow control is next Tuesday. So if you want to learn flow control, join me for the live stream. But I think it's important to start off on a strong foot. Start off understanding how to test the code we write. Because from every episode on from here, we're going to test every piece of code that we write. We're going to figure out how to test it, figure out if there's a better way to write it so that we can test it, or figure out if that's not the best thing to do is to test it. So with that being said, let's jump into testing. If you noticed, we wrote these two fantastic functions right here. We have add and we have add2, but we haven't tested them. So let's start testing them. All right, the first way that we can test, and probably the simplest way that you can test your code, and one of the easiest to add to a pipeline of any type, super easy to add to a GitHub action or even a Jenkins pipeline, is the tool Clippy. Clippy is going to do static analysis of your Rust code, and it's really simple to use. So all we need to do to run Clippy, it's actually really easy. All you have to do is open up your project and run cargo Clippy. Wow, Clippy already gave us some input on our code. Let's go ahead and check it out. All right, the first one here, it says that this is dead code. It's not being actively used. Let's actually fix that. I think we can fix this. So here we can see we're not actually using this code, so it's dead. Let's go ahead and fix this. Let's go ahead and run it. Let's make sure what we did works. Yep, and it's 6. We see that it's 6. This worked super easy. All right, let's go run Clippy again. Cargo Clippy, and we're down one warning. We got rid of this one. All right, the next one. This one is dead code as well. Okay, so our add2 function isn't used. We're just gonna copy and paste this, and we're gonna get this also fixed. Now you might say, oh, dead code, not a big deal. Dead code can be a big deal. It's unneeded complexity, and it really helps you see what you're using. Now at this point, you think Clippy won't complain anymore, right? Everything's good. Visual Studio Code isn't complaining about it anymore. You can see that these have turned their normal color, not signifying that they're dead code. Let's run Clippy and see what it thinks. Cargo Clippy. Oh, Clippy has something more. Now, if you don't understand what's happening here, go check my last video because I did a whole dig into why Clippy might dislike this function. But this is an unneeded return statement. So Clippy is actually checking for even more things. So we can go back in here and remove this return statement. It's wanting it to look like this function. Like I said, we already covered the differences between these and that there's actually none. Clippy, it turns out, doesn't like this style. So you know what? We're just going to delete this. No need to keep it around. It does the exact same thing. Cool. So Clippy does a whole lot more, but that's a quick introduction into the tool Clippy, and just running it by itself like that is fantastic, but you can go ahead and check out all of the different things yourself if you like. If we run cargo Clippy now, you see all checks pass. If you'd like, you can run Clippy help to get a brief preview of some of the things that you can do. These are mostly pretty easy to understand as far as and where you might use them in your CI/CD pipeline. So we can also allow or deny a lint. So specifically, the one with the unneeded return statement is one that I usually let allow through my Clippy pipelines. I like the return statements. But for now, we're going to just remove it and it's good. All right, let's get back to testing. We want to write a unit test for this add function, right? All right, let's do it. Now, how Rust does it is you put it in its own module. There's going to be a few things here that we cover that don't make sense, and do you know what? That's okay. I'll explain some of them at a very high level, and then more of them we'll talk about more later on. So let's get into it. The very first thing is we don't want this code to compile into the final binary if we're compiling for release. We really only want this code to compile into the binary if it's compiling for tests. So this first thing is a configuration flag to tell the compiler when to compile this. To do that, we'll do a CFG for our config, and we'll tell it to compile this code when we're testing. Not too bad. The next thing we need to do is we need to create its own module. So we'll get into more on modules later, but this is how we organize code in Rust. We're going to say mod tests, and we're going to create a scope for our module. Now, really, again, this is going a little bit more into the modules. We're going to say that we're going to use superstar. All this is saying is that we want to use the code from here. If you don't do this, this module doesn't have any idea of the scope ahead of it, above it, and won't be able to actually use it. So star is also importing all of it. This is not getting into proper usage of use statements. This is just a quick demo. All right, so let's write our first test. There is no test, we just have a module here. Let's actually write a test. To write a test in this module, you use the pound again and the keyword test. And at this point, you write a function. So we can do fn test add. Now, we've written our first test, and you can see Visual Studio Code already knows that this is a test, and you can run the test or debug the test. This is super cool. Now, what if I wrote another function? Let's say this does something that helps. We can use this and call this in our test. So not a test, but a helper function. And this is completely fine. So it's okay, and I might even encourage to add some of these. Now, you might find that these utilities are really useful and they can be in a utilities module or something like that. I'm not necessarily saying that you need to do it here, but this is a viable thing to do inside of a test. And you'll notice Rust doesn't see it as a testable thing. This is not a test. It does not run it as tests. It is just a function in this module. Pretty cool. Now, we don't want this, so let's just go ahead and delete it. We don't need it. I was just showing it to you guys. All right, so let's actually test this. We're going to use a new macro. Our first test, we're going to say let x equal 5, let y equals add x, and we're not quite done. We need to compare this and make sure that it's what we expect. So to do that, what we're going to do is we're going to say assert, and we're going to say assert that these things are equal. Straight assert is going to do it based off of true or false. So if you say assert false, it's going to always error. This is assert equal, so these are going to ensure that the two things are equal. And the last one here is assert not equal. It's going to make sure that the things are not equal. So we're going to say assert equal, and we're going to say y, and we're going to assert that it's equal to x plus x. Let's run this. Now, as we can see, our tests pass, but passing, they were already passing. So that doesn't really prove anything. Let's actually see if we can make it fail to prove that this is actually working. All right, let's do this where we add just one. So we just updated add. We made a bug. We've made a bug here. we're now we're making bugs. So this test should catch this error, right? Let's see if it does. And there it does. Our test failed because if you go up here, it panicked and assertion failed. Left equals right. The left was 6, right was 10. Super cool. Okay, let's undo that. We don't want that bug. That's a bad bug. We don't like bad bugs. We really don't like bed bugs, but bad bugs are also really bad. Fixed. And our test is passing again. So this is the basics of unit tests. But you know what? I'm not going to stop here. There's actually another really cool feature that I think you're going to like. Now, throughout this class, we're going to continue to add on this knowledge of unit testing, but we're also going to do doc testing. Yeah, that's right. Have you ever gone to a website that had documentation and the documentation was just wrong? Well, it's super frustrating, and thankfully, Rust has a way to solve that for you. Rust has solutions for all of these problems. So let's get into it. Now, one thing that you might notice here is this has a main function. This is an application. Doc testing only works on libraries, so let's go create a library. Now, that was our CLI application. If you remember, we did cargo new, and then if you remember, bin is the standard, the binary, the application. We're going to do lib now. So we're going to do lib, and we're going to give it the name lib, just to be original. All right, let's go check out our new library. We'll open it up in Visual Studio Code. So this is our new library. How do you like it? Now, when we created the test, guess what? This library came pre-generated with a unit test. This is awesome. So you can see they did pretty much exactly what we did. It generated an add function with a usize. I think we did integers. Well, usizes are integers, but again, architecture specific or dependent. Anyways, they did their usizes, and guess what? They asserted that this was equal to 4. Well, cool. So this is almost exactly what we just did. And we can see that this is a unit test. But I said something about documentation testing. That's right. So RustDoc is a pretty powerful tool, and it allows you to pretty much, it's the standard way to document your libraries in Rust. One of the cool things is it's right in code with you. You can see that as Visual Studio Code already knows that these 3 forward slashes before a function means I want to do some documentation. So in our documentation, it's always really nice to have examples. So let's make an example. We'll just do, we'll do something like this. Examples. And what you can do in this is do 3 tick marks. Just like you would in Slack to say this is a code block. And then what we need to do is we need to do 3 tick marks to designate the end. Check that out. Visual Studio Code already knows that there's code in this documentation. Okay, I'm not going to explain it all, but we have to do use lib. This is the name of our library, which we named our library lib, real original. And we want to import the add. This is that function right there. So we're going to use that, and then we can say let x equals 5, let y equals x, add x and x, and then we can do assert equals y, and you know what? Let's make sure it fails. Let's make sure it works. Let's do. Well, we'll do x plus x here. We'll do this. We're going to make sure this runs. All right, this failed. Why did it fail? This shouldn't have failed. I forgot. Asserts are macros. Again, these are the macros, so assert equals, we have it as a macro. This should now work. And it did. 1 test passed. Do you see that? we're actually testing our documentation. Now, you might say that in our documentation, we don't really want these things here. That's a good point. That's a valid point. That's a valid point. So let's do this. This is really showing what we want, right? This is really cool magic. Watch this. We can run this again. Oh, my bad. There needs to be a space. All right, let's run it again. You can see it passed. What this does is it hides it from the user interface. Again, this is stuff that you don't want to see. And this is forcing it to be true. This is forcing it to be true. Our assert is proving. Watch this. If we do x plus 1, this would be forcing it to be wrong. But if we did x plus 1 here, our docs would fail. How often has it been embarrassing because your documentation has failed? It is wrong, is incorrect, because add changed. This method changed. The public interface changed. Well, you know what? From now on, with this, if this changes, let's say we do the innocent thing and do right, left, middle, and that's a U size. And we're just gonna update this to add middle. Let's run our documentation test. It fails. This is protecting you and your documentation from having these problems. Your publicly exposed documentation is now enforced to be correct. You can't make a code change because this will fail in your pipeline. Now you might say, oh, how would I run this if I wasn't in Visual Studio Code? Perfect question, because you should be running in a pipeline. Okay, so all we have to do to run it in the command line or in your GitHub action or whatever your pipeline is, you run cargo test and then doc. There you go. We can even see that it's telling us that an argument is missing. It's giving us so much information here and helping us and holding our hand doing it. This is super powerful, and I hope that this gives you just a little insight into the power of Rust, how easy it is to test, and how much faith you can have in the code that you deploy and give to others. Not only do you have your unit tests checking your business logic, you have doc tests testing your public API, the thing that you're serving to people, to make sure that the documentation is in line with the actual code. And not only that, you get a really fantastic. Clippy has saved me many a times, pointing out times when I've been doing things that might not be the best for the code. So it's really powerful. All of these tools are absolutely fantastic, and we're going to be using them more and more in the future. So if you've liked this and are following along, next week, live stream is going to be about flow control. We're actually going to be writing some code. We're getting past this and getting to some code. Then we're going to test our code because we're going to test our flow control. It's going to be fantastic. So join me for that. And you can join the live streams or follow along and you can see these videos. We're going to hopefully get more community input with questions that can be answered and solidified in the videos. So I hope you all like this, and I hope you'll join me next time where we learn about some flow control.